Hey, good afternoon, class. I'm sorry I didn't get a video up yesterday. Been a busy man. Today we're going over 12.4 colligative properties for chemistry. These are pretty cool, guys, and it's mostly pretty simple. A lot of information on the board, but we'll go through it at a fairly quick pace. So, first of all, colligative properties are characteristics that depend on the number of particles present and not on the properties of those particles. Basically, it's how many balls are there, not what color are the balls. Okay? So, vapor pressure is one colligative property. Osmosis, or the flow of water across a semi-permeable membrane, is another. Semi-permeable means some things can flow across, but others cannot. Okay? So, vapor pressure is the pressure exerted by a gas on a liquid when they are in equilibrium. What it means by equilibrium, it's not that they have the same number of particles, it's that the evaporation and condensation rates are occurring at the same rate. It's very much like saturation that we talked about. Basically, the liquid and gas are saturated, okay? So, another way of thinking about vapor pressure is essentially how easy it is for liquids or molecules to break away and become a gas. The gas molecules are exerting a pressure on the liquid. The liquid molecules have to overcome that pressure in order to escape. So, because of this, whenever the temperature increases, the vapor pressure will also increase. Whenever the temperature increases, the kinetic energy of the molecules increases. They're moving around more, and because they're moving around more, they're more likely to be able to break away. When they break away, they become a gas and then start exerting a pressure on the rest of the molecules in the liquid. So, an important term to know is volatile. A liquid that can easily turn into a gas is volatile. Common examples of volatile solvents include methanol and ethanol. You have to be very careful when you're dealing with or transporting these solvents because volatile substances can be explosive. They can go boom. Okay? So, we'll get back to osmosis in a little bit. Why vapor pressure is important is because it can affect changes of state that a liquid can undergo. Vapor pressure will elevate the boiling point, make it go higher, and lower the freezing point. An example of this is putting salt on the road. When we put salt on the road, it'll lower the freezing point and keep our roads from getting icy. Okay? So we use these two equations right here in order to find the effect that putting a solute into a solvent will have on the boiling or freezing point. B stands for boiling, it's also evaporation. F stands for freezing. Okay, so the delta means change. So these values are essentially how the boiling and freezing points are changed by putting solvents in there. M stands for molality. Molality is equal to the mole solute over the kilogram solvent. We did some problems finding molality, now we get to use them. This Kb and Kf, don't worry about it, it's just a constant from table 12.7 in your book. That's on page 211. All you have to do is look up that value, you don't have to calculate it, okay? So, to find the new boiling point, we add the delta Tb to the initial boiling point. You'll find the initial boiling point in the same table on page 211. Freezing point is very similar, except we subtract instead of adding. All right, so here is an example where we go over how to find the new boiling point. Notice we have 6 steps here. The first step is to identify the solute and solvent. Our question asks, at what temperature does a solution of 15 moles of sucrose and 15 grams of acetic acid boil? Okay? So for the sake of this question, we're just going to assume the acetic acid is the solvent. So, and we're going to assume that the sucrose is the solute. An easy way to tell, there will always be more solvent than solute. So to find the molality, we first need to convert our solute to moles and solvent to kilograms. Not a problem here, we already have them in those units. Next, we just take the mole solute divided by the kilogram solvent. We'll get 0.3 here. Now we look at the table on page 211, we find the boiling point in Kb. These are the two values from there. We multiply them together. We multiply the molality by the Kb and we get a delta TB, which we will add to the boiling point that we found and get our new boiling point. If you guys want help working through these, I'm available on Zoom. It's these 6 steps, it'll work every single time. The last thing from today's lesson, everything that we just covered for vapor pressure only works if the molecules do not ionize, if they don't break apart. If they break apart, none of that works, okay? So, compounds that break apart or dissociate and can carry an electrical current are called electrolytes. Hey, that's that stuff found in Gatorade. Woohoo! So, electrolytes are awesome. They power our batteries, and they're the basis of every single electricity cell. They're the basis of electrochemistry. Anyway, a weak electrolyte will only have a few molecules dissociate. An example is acetic acid. A strong electrolyte will almost completely dissociate. That's sodium chloride. You can see other examples of weak and strong electrolytes on table 12.8 on page 213. Okay? So, we would normally expect strong electrolytes to produce double the number of particles. You can see this in the formula for the dissociation of NaCl, salt, into sodium ions and chloride ions. Notice we have 1 particle turning into 2 particles. So, we would expect this to essentially double the molality, but it doesn't because the ions cluster together. Okay, you can see an excellent example of this on figure 12.13 on page 213. Okay, when they're clustered together, they behave as a single particle. The more clusters the higher the concentration, the more clusters will form. So eventually, as we increase the molality, essentially it's going to level off because all our ions will be becoming clusters. Okay, now, over to osmosis. Remember, it's the second colligative property that we're talking about. And colligative properties only care about the number of particles. Osmosis is defined as the flow of water across a semi-permeable membrane. Solvent will always flow from high concentration to low concentration. You can see I've drawn black for the direction of the water arrow. The right side has more solute, indicated by red particles, than the left side. So water flows there, and it increases. Osmosis is incredibly important to biological processes. It powers how hydration works in the body, as well as a number of other things. However, it can be bad for the body. So if a cell is too concentrated, it has too much stuff in it compared to its surroundings, water will flow into it, it'll swell. That's called a hypotonic cell. If it swells too much, it'll burst and die. If the cell is a lot less concentrated than the surrounding fluid, it's called hypertonic. Water will flow out of it to the more concentrated surroundings. The cell will shrivel up and die. So it's very important for our bodies to maintain the proper concentration in our blood and surrounding fluids. Okay, I know we covered a lot today, guys. You are all very smart. I look forward to your questions, and I can't wait to hear from you guys. Have a great day.